Hello, and thank you for coming to this talk. My name is Sarah Babinski, and today I'll be talking about using forced alignment on archival materials. The growing availability of archival materials provides research with unprecedented resources to learn about language and culture and to create learning materials. As we all know, being here to celebrate 100 terabytes of data on the PARADISEC archive. Collections provide an opportunity for researchers and community members to create new resources and knowledge about the language. But as researchers, we're usually taught how to make our own archival deposits, but not how to use existing collections. For a broader discussion of this issue, see Claire Bowen's talk tomorrow. One major step that we can make towards making collections more usable is automatic alignment methods, which is what I'll be focusing on today. So when we want to use an archival deposit, what do we need? This will differ, of course, based on what project we're working on. But basically, what we have in most cases are audio files of running and elicited speech and transcriptions. And sometimes these are time-aligned at the sentence or phrase level, sometimes they're just sort of in a text document. And what we need are time-aligned transcripts, specifically word-by-word alignments, which will be great for dictionaries or online learning materials, and segment-by-segment alignments, which are important for phonetics and phonology research. And so the issue is that most of the time, archival deposits are not already in this form that's easily usable by those of us who want to use them for another purpose. Archivers create the resources that help them in their work, which is great, but that doesn't always align with our needs as users of the archive. And there are several automatic computational methods that can help us process archival materials further. One of these, which is what I'm focusing on today, is forced alignment. So what is forced alignment? Manual alignments are extremely time-consuming, but automated methods can save time, and they're just as accurate as manual methods when the alignments are manually checked after the fact. For more information on using forced alignment, specifically with under-resourced and endangered language data, see DeCanio et al., Johnson et al., and Babinski et al. Forced alignment algorithms make use of automatic speech recognition toolkits, or ASR toolkits, to create word and segment alignments to audio given a transcript. In this talk, I'll be focusing on the process for using the Montreal forced aligner, which is the forced aligner that I am accustomed to using and which is good for training models on small amounts of data. So the first step in the process of forced aligning your audio is that you need uncompressed audio files, such as WAV files, with the same sampling rate. There's a wide range of sampling rates that will produce good alignments, but they all need to be the same as one another in order for the aligner to run. And we need transcriptions at the phrase or sentence level. Time-aligned transcriptions are best, such as an Elon or Toolbox, but automatic alignments can deal with unaligned audio. They'll just require more manual correction after the fact. So with this in mind, a note to those of you who are thinking about depositing your materials into an archive is that consistency is key. So having the same file types, having the same file formats, sampling rates, using standard transcription practices, and just overall being consistent in your data will make it a lot easier for those who want to use your materials in the future to do so. So once you have the files you need, preparing and running the alignment is relatively simple. So from an Elon file, for example, you can extract a list of words which will help in creating the dictionary file. And you can extract the transcription tiers as prop text grids, which will be directly inputted into your aligner. And you want to create a dictionary file. So for this, you will provide the transcription of each word in that list of words that you extract in some standard transcription format that matches with the aligner that you're using. So in the Montreal Forced Aligner, this can be ARPABET or Global Phone transcription standards. So this will just tell the algorithm what each word should sound like. And finally, you can now run your forced alignment. So the input for the Montreal Forced Aligner includes a folder with the audio and text grids that you want aligned, your dictionary file, and a training model. Now you can train your own model on manually aligned data from the language that you're working on. This can be very time consuming if you don't already have some manual alignments available. And if you use English or another well-resourced language as your training model, there may be slightly more manual correction that you need, but it's really not a huge addition to the amount of time that you will spend checking the alignments after the fact. And so once you have those alignments, you run them and everything works out great. Your text grids are ready for manual checking and correction. So great, you are now able to use forced alignment to process archival materials and use them for purposes that they maybe weren't originally created for, and to continue to enrich these the knowledge of this language and create your dictionaries and your materials. But what do you do now? So I would encourage you to share your results. So if you send in your word and segment level alignments back to the archive to be added to the deposits that they came from, you can save time for future archive users and further enrich the original deposits. And adding to the existing archival deposits can lead to a future of even more accessible documentation of language and culture, so that we can continue to use these archival materials in a dynamic way over time and really get the most out of the documentation that people put so much time into. So thank you for coming to this talk. I am looking forward to your questions, and here are my references. Thanks.